Hi guys, I'm Bisa. Today we're going to learn about Lambda calculus. So it's going to be sort of a different sort of video compared to my other ones. We're going to get into the actual, actually doing the Lambda calculus later. But now I'm just going to explain the concept or whatever. Okay, so Lambda calculus is a programming language. In Lambda calculus, there there are no numbers, no strings, no anything. The only thing you can do is make variables. Oh wait, not variables, I mean functions. Language calculus is a functional language, like something like Haskell. So yeah, we're going to get into how it works. So, start by creating a function. To make a function, you use this Greek symbol lambda, and then you basically just write, well, the name of, oh, not the name of the function, the arguments of the function. And let the calculus functions only have one argument and only one forever. But we'll find a workaround to that later. So anyways, lambda, let's call the argument x. Let's have like these. So let's call the argument x. Lambda x. Then we put a dot to separate the argument from the real function, you know. So lambda x dots. So here we're going to state what we're gonna do with x. So let's say I don't know, x plus 1 or something. Then yeah, it's going to add 1 to x. So how do you actually like run these functions? Well, not really run. Yeah, you know what I mean. Okay, so like if you want to run this function, you have to put it in brackets, and then the argument. So x is the first argument. So let's say I don't know, alpha or something. So then it's going to get, like simplified or or whatever. So let the x equals x plus 1. So what's it mean? We have to bring this x plus 1 down here to turn it into a plus 1. And yeah, that's basically it. Hey, wait, I said that there's no variable there. Of course, how could there be a? Well, there isn't. Okay, so, well, yeah, we can also assign a name to these functions. If using the computer version of the calculus, so that you can, so that you can, like run on your computer. You're gonna be able to assign names to these things. So, like, let's say I want to call this true. Okay, not true. That's a horrible name. Let's just call it f is equal to whatever this is. So we won't need these brackets and all that stuff. So if I want to run the function now, just have to write f a or alpha or and whatever the argument is. Okay, so yeah. Alright, so I said that I would come to a workaround about having a function with multiple arguments. So like let's say I want to make an adder function. So I'm going to say add is equal to a lambda function, just lambda sig. It doesn't really do anything. It just signifies how you're making a function. So I'm gonna say lambda x is at dot lambda y. So then dot y plus x, and yeah, that's the function. So how this is gonna work is that, okay, so first you're going to execute this one, that's all on the inside. So it's going to become, okay, so let's say we're running this function. So let's say I'm going to show to add to a dot y. So let's say alpha of 5 and 2 or something. So we're gonna do alpha of 5 and 2. Is that yeah. So we're just going to say, so I'm going to execute this y function first. It's going to become the x dot. So here it says y plus x, and this one is 2. We're going to say 2 plus x. So now I have to execute the lambda x function. So the return value, the real value is just going to be 2 plus x. Here, since x is 5, we can just say 2 plus x, which is 7. Alright, so what I'm doing here, I mean, it isn't really real when we hit the calculus. As I said earlier, there are no numbers. There's no nothing, just functions. If you want to make numbers, then, well, duh, you have to use a function to make them. So, well, let's start with something simpler, or not simpler. Start with true and false. As I said, nothing but functions, so we're gonna have to define true and false ourselves. Let's say t is equal to, so let's say t is equal to, make a new function here by some lambda. We'll just zoom in a little. So t is equal to lambda. So I'm gonna put the arguments here. No, the arguments will be true and false. So out of those true and false, it's going to pick true. So I'm going to say t, and the f will be the same thing. So f to lambda t, that's lambda f. That's going to pick f. Okay, so yeah. Okay, so for some reason, there's no earlier video, so yeah, I already know all this, so I have to explain it again. So this process is called beta reduction or beta reduction. It happens from left to right. It's basically the process of just like simplifying the thing. We just copy this lambda symbol. Okay, so we're gonna go through the whole thing again. So, oh yeah, that's the end function. Lambda alpha or lambda beta dot alpha well, yeah, you get it. Oh yeah, F here stands for false. So knows us. Alright, so let's say and true, false. The real answer is supposed to be false. But will it be false? No, no one knows. Actually, we will know when we try it. Okay, so first the and function is lambda a dot lambda b dot ab false. So if we run this function, I'm gonna put it in brackets to separate it. If we run this function on true, false, then a is gonna be true, b is gonna be false. So it's basically gonna be true, false, false. So then the true function is here, as I was done from left to right, so it's the left one. So the true function is lambda t dot lambda f dot t. Gonna put in brackets as usual, and false, false. So it's like the first argument is false. So which means that's basically just gonna be false, false, and then the false function is we put in brackets. The false function is lambda t dot lambda f dot f, and then it's gonna run on false, and so the real answer is just gonna end up being false. And yeah, that's basically how it works. We also do other basic operations with lambda calculus, but we're gonna look at those in the next video. So anyways, that's the end of today's tutorial. If you enjoyed, leave a like and subscribe. So bye.